Everyone. In today's video, we are going to solve the questions of exercise 7b. It is from book D3, 8th edition. Topic is mensuration of cones. Exercise 7b is about the surface area and volume of cone. And before starting the questions, we need to go through the complete introduction of a cone. So let me show you what a cone looks like in real life. So here is a cone. You can see that in this we have the tip of the cone, which is called the apex of the cone, and then this height, that is called the slant height. And from the tip of the cone to the center of its base, let me show you first the base. The base of the cone is a circular base, and this is the here is the center of the cone, center of the base actually. So from this point, from the center of the base, we draw a perpendicular distance to the tip of the cone. This is called the height h. Similarly, as it is a circle, so its perimeter will be 2 pi r and its base area will be pi r square. And this surface which you are watching now, this one is called the curved surface, and the curved surface area will be pi r square, pi r l. I'll be writing all these formulas in front of you, and then we will be solving the questions given in the exercise. So now here we have to find the volume of each of the falling cones. As I have told you about the different parts of the cone, so the formula for the volume of the cone is V equals 1 over 3 pi r square h. Keep in mind that this formula is just like the formula for a pyramid, which was equal to V equals 1 over 3 base area multiplied by height. So this base area in the case of pyramid was in form of different polygons like a square or a rectangle or a triangle. But in case of the cones, it will be only the circular base. So we use pi r square as the base area. So in question number 1, part A, we have the radius which is equal to 6 centimeters and height which is equal to 14 centimeters. So using these values in this formula, we get V equals 1 over 3 multiplied by pi, and R is 6, so 6 square, and multiplied by H, which is equal to 14. So solving all these values, we get 168 pi, and putting the values in calculator and writing the answer correct to three significant figures, we get 528 centimeters cube. It should be, as it is the volume, so we have to put a centimeters cube here also. Similarly, in part B, we are already given the area of the base 154 centimeter squares, as we are given the area of the base. So using this formula, keep in mind that pi r square is area of the base. So we don't need to find out what the value of r is. And so part B becomes volume equals 1 over 3. Instead of pi r square, we get to write 154 centimeter squares as the base area, and height of the cone is given to be equal to 5 centimeters. So just put a 5 here, and solving this part, we get 770 divided by 3, and in this case it will be, just a second, 256 whole 2 over 3 centimeters cube. Or we can write this again correct to three significant figures is 257 centimeters cube is the volume of part B's cone. In part C, you are given, I will not be writing, or I will not be solving this part C and D, just it will be explained like this. We are given the diameter of the base, so half of the diameter is the radius. So you have to use 3.5 as r, and height is given to be equal to 14 centimeter. So using 3.5 in space of r, and for h you will be writing 14 centimeter, you can easily solve. And in D part, we are given the height and circumference of the base. Yeah, in D part, first of all, as you are given the circumference of the base, so find the value of R. We have to find the R because in formula of volume we have to use it. So circumference of a base is basically the circular, so circumference is 2 pi R, and this is equal to 132 millimeters. You can solve this by making R the subject of the formula. 132 divided by 2 pi, you will be getting some value, and you can easily solve this part by putting the value of R, which you can find from this later on in the formula of V equals 1 over 3 pi R square H. So you see that this question was easy. In question number 2, we have a cone that has a base area of 20 meters square and a volume of 160 meters cube. So this question is a little bit different from question number 1, where we were directly given the radius and height. But now in this question, we are given the base area, and we have been given the volume. So as base area is equal to 20 meters squares, and the volume is 160 meters cube. Find the height of the cone. We need to find the height of the cone. Volume is equal to 1 over 3 pi r square h. Using the given values in this formula, we get V, which is equal to 160 meters cube, 160 meters cube, which is equal to 1 over 3, and pi r square is the base area, which is 20 in this case, and h we need to find. So you can see that just making h the subject of the formula, we get 160 divided by 20 multiplied by 3, and it will be easily solved, like it is 8 threes are 24. 24 millimeters, sorry, 24 meters is the height of this cone. Now moving to the question number 3 and 4. Question number 3 says the volume of a cone is 320 pi. So volume is equal to 320 pi centimeters cube, and its base area is pi r square. So base area is directly just pi r square, where r is a prime number. Suggest a value of r and find the corresponding height of the cone. So you see that we have a sign written as open. It's an open-ended question, like as they have given you the authority to suggest a value of r, so you can take any value of r, but keep in mind that that value must be a prime number. So before starting this question, just formulate an equation. So volume is equal to 1 over 3 pi r square h, and volume was given to be equal to 320 pi, which is equal to 1 over 3 pi r square as it is, and h as it is, as we do not have any value for r and h. The value of r must be a prime number, and it must be given by u, means you can take any value for this question. Before moving forward, see that this pi will be cancelled by this pi, and 320 multiplied by 3, we get 3 zeros are 0, 3 twos are 6, 3 threes are 9, 960 equals r square and h. Let's say that r is equal to any prime number, and it may be 3, it may be 5, it may be 7. I would suggest that you take a value which may cancel the like which may divide this 960 easily. So we will take r to be equal to 5. So 960 equals 25, that is 5 square, multiplied by h, and h is equal to 960 divided by 25. And solving this by using the calculator, you get its answer to be equal to 38.4 centimeters, which will be the height in this case. As this was the open-ended question in your examination, such questions will not be asked. This is just given for your own practice. So question number 4 says a cone has a height of 14 centimeter and a volume of 132 centimeters cube. Find the radius of the circular base and take pi to be equal to 22 over 7. Here you are asked to use the pi equal to 22 over 7. So we will not be using any other value of pi, like that will not be appropriate to use 3.14 or any other value. So volume of the cone is equal to, in this part, 1 over 3 pi r square h, and using this information, 132 is the volume, and 132 is equal to 1 over 3, and instead of pi you are using 22 over 7, and r we need to find, so it is just r square, and h is equal to 14. It will be cancelled, like 7 2s are 14, and we have 132 multiplied by 3, which is equal to 22 2s are 44, and it is 44 r square. Further, r square is equal to 132 multiplied by 3 divided by 44. Using these values in calculator, we get r square equals 9, and this gives r to be equal to 3. Keep in mind that when we take the square root, we get two values, positive and negative 3, but negative 3 will be omitted because r is a length, and lengths can never be negative. So the last question of this video is question number 5. We have different parts for question number 5, and in this part we are going to find out the total surface area of each of the following cones. Formula for the surface area, again let me show you what a cone is. So here, the surface area of cone is of two types, like this surface area, which is called the curved surface area, and the second surface area is this base area. So keep in mind that the curved surface area of the cone is given to be equal to pi r L, where L is the slant height, and the base area is pi r square. Moving back to the questions, here we have to find the total surface area of each of the following cones. So in part A, you see that slant height is given to be equal to 7 centimeter and radius is equal to 4 centimeters. So there are two areas. Number one is curved surface area, which I told you that it is pi r and L, and the second one is base area, which is equal to pi r square. So in total, the total surface area of the cone is equal to pi r L plus pi r square. So finding the curved surface area first, we need pi is equal to, it should be pi r L. So pi's value I will be using from the calculator, and pi multiplied by r is 4 and L is 7. Using these values in calculators, we get to be equal to 28 pi, and we have to add the pi r square formula. R is equal to 4, so base area is equal to pi as it is, and 4 square is 16, so this is equal to 16 pi. Adding both values, we get total area, which is equal to 28 pi plus 16 pi, and the calculator gives the values to be equal to 138 centimeters. Keep in mind that this is centimeter squares, and I have given the answer correct to three significant figures. So it is 138 centimeter squares. In part B, you see that we are given the slant height, which is 30 millimeters, and its diameter of the base, which is 28 millimeters. The question will be solved on the same lines, but instead of this 28, you are supposed to be using 14 centimeters as its radius, so 14 millimeters, sorry, as its radius. In part C, we are given the slant height and circumference of the base. From the circumference of the base, We have solved such questions in previous parts, where you need to use first 2 pi r, which is equal to 132, and then r will be equal to 132 divided by 2 pi, and your calculator will give you the value of r, which you can use in this formula again, finding the curved surface area and base area, and then adding both values to get the total surface area. So we have solved question number 1 to 5 so far. Um, the remaining questions will be solved in some other video. Until next time, thank you very much.